So just make sure you put all phones away, headphones off, so that you can focus. You need to focus, all right? So both of these, I just have a bunch of information in terms of the lifespan, okay? I put this into L1, L2. I notice that there are 30 values so in this case we're talking N represents what? Number of batteries, right? Number of batteries. Every single one is a lifespan of a certain battery, so make sure you understand that. So 30 batteries, if you want to make a note of that. Okay. And then we figure out and compare them side by side. So the mean is very, very close to being the same, right? The average is about the same. The median is exactly the same. But what do we notice? The standard deviation is different, correct? What does this tell us? If I asked you use the standard deviation to describe the data, I do talk about it later on, but let's just do this right here. You can do one of the two, okay? You have a choice when I ask you to explain. You can focus on this number and just say that brand X has a greater standard deviation, and that means a lot of things to us. It means that the lifespans are spread out, okay? There's variation, lack of consistency, all of that you can talk about. And that goes back a few pages where you have that summary of what standard deviation tells us. You can say that the range is going to be greater, anything like that. Or you can focus in on this number and just talk about brand Y, telling me that, hey, it's got a low standard deviation, data is going to be a bit closer clustered together compared to the other brand, right? It's more, the range is smaller, it's more consistent, and so forth. Okay, so you have a choice what you want to do there. You just have to know what does that number tell us? And in this case, we're comparing, so it tells us a lot. Usually if you just have one standard deviation, it doesn't tell you a whole lot, but when you start comparing it to another set, that's good. So, and this could translate to marks. Like this could be student A, student B. These are the AC marks that were recorded over the period of a semester, right? And then you do this and you find out, right, this student was more consistent in terms of AC marks than that student, right? So this can translate anywhere you want, and it will, it should be the same sort of way of answering. And then you notice also, right, higher standard deviation, higher range, no surprises, right? Basically, when you graph this and you take the extremes, they will be further apart if your standard deviation is greater. Okay, that's just another thing you should be observing. And versus this brand is closer together. The mode is also fairly similar, but not quite. So the standard deviation is the one that tells us everything behind. So when we're talking, not every teacher does this, but I do it. Averages don't mean a whole lot. Okay, averages without a standard deviation don't mean, because you could have a high average in the class, and it could just mean that there's maybe 5 students that score like 90s or 80s, 90s, 100, and they just drag your average up, right? But what I would be interested in is like, well, what's your standard deviation? Like, what's the spread? Like, I want actually most of my students to be closer together, because that means we're consistent, right? We're consistent, and we can work with that to bring up your mark, okay? When you looked at the graph, I don't know if you did the line plot. You need to be able to create a line plot. When we're comparing two sets, we ideally want to have the same scale. Okay, we want to have the same scale so we can see. And sure enough, brand A, if you think about it, brand Y. Brand Y is a little bit closer together. This one is a bit more spread out, right? You can actually see that visually right there. So, and that is what you did expect. And make sure you always label mean, median, mode, because probably tomorrow or like there's going to be line plots throughout this this unit. So just be ready to, and make sure you label everything. Like, what is this? Technically, this should have been probably brand X in years, but lifespan would probably be even better. but just have some sort of label on there. And then we took it further. Maybe the key you got is a little different because I've got like various slides of this. So brand X has a slightly greater mean, greater range, inconsistent lifespans. Greater standard deviation means that data is more spread out. Okay, so you don't have to do both. Pick, right? Just talk about. I do want to see keywords are standard deviation and range, right, and so forth. What does a higher mean indicate? A higher mean, if you just want to talk about the mean, it just means that the lifespan in general is a little higher. So which one of these two brands has in general a bit of a higher lifespan? Slightly. Brand X is slightly higher. Just slightly higher. In general, the lifespan is greater. But we see the inconsistency later on. So which one would you recommend? To be honest, there's no right or wrong answer here, but I would say brand Y, since it is more reliable, more consistent, it's got the lower standard deviation. Okay, what other factors should you include? Of course, the price, warranty, because if the brand Y is twice as much as brand X, I might still go with brand X even though I know it's not as consistent. I'm going to take the risk there, right? So that's fine. Customer service, maybe the brand itself, like how well known is the brand, right? So things like that, obviously, we would consider as well. So that is that. The other one I want to talk about is on page 11. I'm not sure if you did that one. That one was kind of above and beyond what I assigned. If you didn't do that one, okay. So page 11 has two unit tests, right? Unit test 1, unit test 2. And how about this? We'll split up the room, okay? So let's, unit test 1, we're going to split it right here. We're just going to do, you guys are going to find the mean median mode for the unit test 1, and you're going to find the mean median mode for unit test 2 real quick. Otherwise, we spend too much time on this. And then the key here is to explain what we're doing, okay? If you have time to do both, sure, do them both. All right. What's the verdict here? I meant to say standard deviation as well, right? Mean and standard deviation. Unit 1 test, so what did we get for mean and standard deviation? 71.2. Okay. And in this case, we don't know what the units are, but what we can just guess that it's going to be percentage. I should have given you that. And standard deviation, 6.55. 6.55. Okay. Okay, and then we're going to do unit test number 2 over there. Any brave volunteers? What did you get for mean and standard deviation? 71.2? Yeah, okay. And standard deviation? 16.07, right? Okay. All right. So if I ask you to explain using statistical terms, how about graphically? Let's figure this out graphically. If we would, this is just a sketch, it's not to scale. If we would have our bell curve, unit 1 test compared to unit 2 test would be what? Which one would be clustered together, have a steeper curve? This will be steeper, right? So you would expect something like this, right? Something, everything is clustered together, versus if you want to talk in unit 2 test, it's going to be flatter, more more spread out. Okay. So that's one thing in terms of observation that you can think of. What do you notice about the mean though for both of them? Exactly the same. I don't know if I talked about it in that first video, but usually the center of the curve, like right in the middle, is where our mean is. So both of them are kind of like having that average of 71.2, that's the middle, but we have different standard deviations. Okay. So we can say this. What does n represent here? Tests, yeah. Test scores. Tests or test scores, both would be fine. It's just not percent, right? That's something, if you did this correctly, you have 25 for each. So let's describe this set, okay? Both classes had the same, and you can write this down, overall average. And we know that because of the mean, right? Unit 1 tests were more consistent closer to mean. I need to zoom in a little bit. Yeah. So unit 1 tests were more consistent, closer to mean, because, let's be specific, how do we know this? Because the standard deviation is lower than the scores for unit 2 tests. The bell curve for unit 1 tests will be steeper, showing that the range is smaller and data is clustered around the mean. That is a lot, to be honest. Do you need to write that much? No, but I'm trying to let you, I'm trying to give you different avenues to make your point. And specifically, I do talk about the mean and what does that say, right? I do talk about the standard deviation and what does that tell us, right? So you're making specific connections to those numbers. Okay? And if you want more, pages 12 and so forth have page 12 in particular. Okay, if you want more like this, page 12. But this isn't going anywhere. We're going to do more of this as we progress, as we go through the different topics we cover. So I just thought I highlight this before we move on. And of course, you could have gone the other way. You could have talked about unit test 2. It's going to be more spread out. It's going to be, data is going to be further away from the mean. The range is going to be bigger, right? All of those things if you chose to do it that way. I don't have a preference. You decide. As long as you're consistent, you're not contradicting yourself, you're fine.